2.6, number 33, is an interesting exercise here, guys, in the idea that it's possible with some of these trigonometric limit problems to get the to get the right answer, but for a reason that makes no sense at all. And I got to warn you guys here that that is not going to get you full credit on a test or a quiz. So do me a favor, don't write down anything I'm about to do. What a lot of people want to do here, guys, is just pull the 7 out in front of that 7 sine theta and pull this 3 out in front of the sine of 3 theta, and then just kind of introduce a theta here somewhere and say, oh good, now I have sine of theta over theta, and so on and so forth. But guys, you cannot just pull the 7 and the 3 out in front. 7 sine of theta is a function that looks very different than the sine of 7 theta. Real quick, and there's no need for you guys to write this down, but if I were to graph those real quick, the sine of 7 theta is a sine wave that's got a really short period. It kind of does something like this here, guys, where it's going to go do 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 like that. So that would be something like the sine of 7 theta. But 7 sine of theta is going to be a much taller function with kind of a normal period that looks like that. That would be 7 sine of theta. They are not the same function, really, for hardly any x values here at all. So we got to get rid of that idea. You are stuck with the coefficients there of 7 and 3. You're never going to get rid of them. So what can you do? You can work this around a little bit to make the one trigonometric limit that we need to know work. And here's what it is. You're stuck with the sine of 7 theta on the top. What you need, though, then, is to introduce a 7 theta as a factor down here in the denominator that I can pair together with that sine 7 theta on the top. Now, you can't just multiply the bottom by 7 theta. You need to do the exact same thing on the top as well. So on the next step, you're going to see me rewrite this in a slightly different order, and maybe it'll be a little clearer why I did that if you can't see it already. However, at the same time, in the denominator, we've got a sine of 3 theta. You can't pull out the 3. You're stuck with sine of 3 theta in the denominator. So I need to introduce now a 3 theta on the top that I can pair together with the sine of 3 theta on the bottom. And of course, if I do that, I got to put a 3 theta on the bottom as well. So where are we now, guys? This is now the limit as theta approaches 0 of, and I'm going to start a big bracket right here. Now, I basically have 3 factors in both my numerator and denominator. I can pair them together any way I want. So I'm going to make the first fraction here the sine of 7 theta, so that takes care of that, over this 7 theta right there. And hopefully you're going to look at that and go, oh, I know what to do with that. For my second fraction now, I'm going to take this sine of 3 theta on the bottom, and I want to pair that up with this 3 theta up here on the top. Okay, hopefully we know what to do with that. And now times, what does that leave over? A 7 theta from the numerator and a 3 theta from the denominator. Now, the one thing I'm hoping you notice right away, those thetas just cancel each other out completely. And if you look this problem up in the solutions manual, that's where that weird 7/3 comes from. So if you're confused on how they got it, it's actually 7 theta over 3 theta. They just canceled out the thetas. Now, we can use the product law for limits that says the limit of a big product is equal to the product of the individual limits. In this case, there are 3 of them. So really what most people like to think of is that we're distributing a limit here. That's really not the way we're supposed to look at it. But yeah, that's essentially right. So here we go. The limit as theta approaches 0 of sine of any angle over the same angle is just 1. Times, same thing now, the limit as theta approaches 0, okay, of 3 theta over sine of 3 theta. You'll notice that this middle factor here is kind of like a reciprocal of this one here. So really, our answer here for this middle part would be the reciprocal of 1, which of course in this case is still just 1. And then times the limit as theta approaches 0 of 7/3 is just 7/3. The value of theta doesn't impact it at all. So we're going to multiply 1 times 1 times 7/3, And that's going to get us our answer here of 7/3 for problem 33. And that's how you get that answer in a mathematically sound way, unlike pulling out the 7 and the 3 out in front, which doesn't make any mathematical sense. So we've got to make sure, guys, not only are we getting the right answer to a problem like this, but are we getting it in a way that makes sense mathematically. If you guys want full credit on a problem like this on a quiz or a test, the method that you use has to be mathematically sound.